Hello, everyone. Welcome to Cloud Computing and Big Data, Parallels in Scalable Machine Learning and Deep Learning. Today, we have our practical lecture 5.1, Understanding MapReduce in Cloud Applications. And this is a quite complementary lecture, again, to our lecture 5, where we learned about the MapReduce computing paradigm. So let us review what we had the last time. So we talked about a traditional approach in computing science, basically called divide and conquer, that you have a large problem to solve, maybe gigabytes, terabytes of data you want to analyze, but you have, let's say, different workers that can break this problem into different smaller pieces, and then you just want to aggregate the results. So hence you have a partition step and then a sort of combined step. And this is really a very old traditional paradigm really in computing to do. And this is, of course, now the scalable part here, using more and more workers where the cloud then comes in. And we talk about this of being a traditionally nicely parallel, or in previous times, embarrassingly parallel idea, because these workers essentially don't really interact, right? They can solve different pieces of the problem without having large communications with each other. But rather at the end, you would, of course, use all the results and to do some summary statistics or to combine it to the bigger picture. And this is essentially also the idea of the map and reduce framework. As we had in the last lecture, the map task is what you would program in the reduce task, but you program it in a way to leverage really the key value pairs aspect. So I was alluding to the idea that actually map reduce is not like this. It's really map, sort, shuffle, group by keys, and then reduce. That you see a little bit in this explorative here picture, where the framework helps you a lot by grouping the keys, sorting them, and so on. And this is where really the power of this framework also comes in, combined, of course, with the underlying HDFS, the Hadoop distributed file system, that is a little bit more on the data side, as we have discussed, putting then aspects into the situation like data locality with this data nodes, right? Also today, we will see like in AWS services, they have some core nodes as data nodes and then some task nodes where data is not so important just to compute. But here the framework is ready to work on these different blocks of data, right? We call that sharding. So you have a large data file, which is then distributed really across different nodes. And the replication scheme enables then even the resilience or the fault tolerance, if you want, right? So if one data node is off, you maybe can imagine that the different parts of this file are also replicated somewhere in the cloud. And the beauty is you don't have to worry about anything of this. You configure it a little bit. You want to have 3 replicas because it associated also a little bit with costs, for instance, right? You take 3 times the capacity. But then it enables you also to put more workers actually close to the data when there are more blocks like this. So this makes it also quite fault tolerant, which was another goal of this framework. If you compare it, for instance, again to the high performance computing world, right? This is another goal of this. And it gave rise to quite a lot of stack parts. We call it the big data stacks or the big data framework ecosystem. This is a little bit what you see here. So all are based on map reduce tasks. If it is metadata management or NoSQL database, Apache Hive, Pig for scripts, Mahout machine learning, where map and reduce is already implemented for very interesting machine learning problems and algorithms like decision trees, random forests, but also recommender engines like alternative least squares and things like that. And this is really the heart of it, this Hadoop and this MapReduce, the implementation. And Spark, in a way, is now a similar implementation as we learned in the last lectures, but now on steroids because it takes much more the memory into account. However, the traditional idea of this divide and conquer, of map and reduce remains. And you have seen like with very little coding, you can here and there make quite a difference for this. If you want to have, for instance, a word count was basically done with a one-liner, and we show that again today. You also can explore that if you look in all the hyperscalers like Amazon Web Services, Azure, or the Google Cloud, they all have a sort of service that is basically very similar, addressing the requirements in big data to really work with these different scalable stacks. And you can scale them up and down because the heart in it is still map and reduce tasks where you have more workers doing the maps, more workers doing the reduces. And with this comes the scalability in all of these different platforms. Now we had last time Azure, and I would to go back to Azure a little bit, but then also today I would like to show you more in Amazon Elastic MapReduce. Hence, it's a lecture that is actually complementary to lecture 5, more on a practical basis. We will, in the first part, we will a little bit look on some elements of the Amazon Web Services to start from, but also we'll reflect again on MS Azure again and again. We will basically show you a little bit how the Elastic MapReduce can be used with different options, and unfortunately we see more and more options are vanishing, so you have to swipe the credit card for this, but there are different approaches possible. Then we have some already ideas how to then in the second part use these services. We have to prepare the environment with so-called Elastic Compute Cloud services, which are underneath, and create some SSH key pair, because not all of you are knowing what an SSH key pair is. I'll also bring a very short, let's say, introduction to this topic before we review some very small applications that make use of AWS Elastic MapReduce in practice, which is Airbnb and Spotify, for instance. Then in the second part, we look again on MapReduce in cloud from a different angle. If you want, we want to really look at AWS more. We want to understand now the dependency of these services to the EC2 underlying computing infrastructure. In lecture 8, we will see this again when we come to infrastructure as a service, but this is already sort of one of the idea of having an infrastructure as a service, EC2, and having some higher level services like the EMR as a platform really for data science on top of it. But then we come quickly to the idea that many others as a platform want to use it. So you have to have identity and access management of different EIM users. I will show you this, how that works in the AWS with sort of permissions and groups we will talk to very quickly, because all of these topics could easily fill a whole lecture, right? More than even 2 times 40 minutes. But Amazon is very rich in configurations, almost like MS Azure, but AWS is maybe a little bit bigger in all the possibilities of services in configuration options. And another part I wanted to show you today also is how you can nicely connect now this AWS EMR service also with storage solutions, where you maybe use a Python script for an application and not only do Jupyter notebooks, right? So Jupyter Notebook will be briefly addressed because it has also lots of permissions required to use it. But here I also want to show you another case where you can automate this, not interactively as we have seen with the Jupyter Notebook, cell by cell by cell, but also have a, let's say, Python script that can maybe run overnight without a human interaction and then deliver you in the morning the results. And I brought you an application of food inspection data, again, a little bit different than you know from the previous lectures, but still captures the essence of how that can be done very nicely in parallel to count basically red flag violations. With this, you basically also understand that the S3, although its data can be also used for applications, and how you can connect this to the AWS EMR services. With this, we fulfill also several promises, obviously, from lecture 5. So let's go and start with the first part. Hence, fasten your seatbelt for a practical lecture, lots of jumps between slides and different elements I want to show you either in the cloud vendors or on some websites. Again, revisit briefly the origin. Coming from Google, it has now basically reached all the different cloud vendors. This was at times where Google was actually almost still beta, right? So this is an interesting time period where Google became stronger and stronger. And it has really stood the test of time, this MapReduce framework. It's of course not used for everything. I was telling you already for graph, we have some graph approaches these days and so on, but still many of the applications can make use of this interesting paradigm, HTC, divide and conquer, MapReduce. And I think just to repeat here again, this is important for the conceptual understanding, right? When you see the key and values, which you basically create out of the map tasks, yeah. Then you have your grouping by keys to these different inputs that you resolve, which is done nicely by the framework. Hence, this is something where there's some magic happening to really understand this. And the reduced task then is defined just basically on getting the keys and lists of these values that you then can simply combine to an output, also distributed, of course, but then combine all into one let's say, part A, part B, part C outputs somewhere that we want to store, for instance, in S3 later. So it's broadly used. I told you already. It's also not completely new. I've done this also and talked about this already in the, basically reflection on the last lecture. The MapReduce paradigm is implemented in Hadoop, but also in Spark, basically, as we have seen in one of the recent lectures. Hence, we will leverage what we learned with a Spark cluster and also will enable us then to use this. But I will also show you that, of course, you can create a Hadoop cluster in MS Azure. You don't necessarily need to have Spark, but because we know already a lot of things about Spark and we have learned it's quite a sort of better framework if you want, because it leverages memory these days. So hence we will go into this direction. So the data is the application example we know from the food inspection. Because it's uploaded already, it's a bit easy in the MS Azure example I want to show you. And what we actually will use is just the README, basically the metadata around this. So don't get confused that we don't work on the inspections on this data set, but rather thinking about essentially a README file that goes along with this example. And there we want to just count the words. So the simple word count application we did already in the couple of lectures, and I think it's really a nice example because it's very simple to understand that for every element you have to really program yourself, right? So this is a map task you have to implement really. You have the reduce task you have to implement, and here's it's very clear from the occurrence. You say for each word that you have, maybe you go line by line through this. You have basically then always each, word will be word, whatever the word is, occurrence 1. Word occurrence 1. Let's say if the word occurs a couple of times, it's still 1. Hence, you end up with a very long list that we will also see later with ones. So just, of course, in a very distributed fashion. And the framework really will make sure that the workers get all, these map tasks to the data sets, that the number of workers are leveraged depending on the, massive amount of the data that you would have. We will start with a small README, of course, but think about that usually people would maybe do this now for a large set of documents. Hence, here you have another possibility to see that this framework enables us really for a very quick implementation of this, word count application, but also thinking about now machine learning topics will have other map tasks and reduce tasks. Quickly thinking about the magic that I was saying to you, grouping, sorting, and shuffling around keys is happening by the framework. So you are just responsible then to work on the keys, and you get a sort of list or iterator if you want through all the values that have been sorted or shuffled if you want, because it was distributed, if you remember, through different map tasks, then coming back to one line, and then it's up to you what you want to do with it. Here you can imagine what we want to do is in all of these different values, we will expect that by the same key, we would have lots of ones. And every time we see one occurrence in this list, we just have to do basically then the kind of list values of the occurrence of the word. So I think doing this in practice, we'll see a little bit similar elements. And here's the more abstract way of seeing this, but still the key essence to have this as a key value, and then you have the key, and then this kind of list of values. But think about, of course, that in between the sort, shuffling, and grouping is happening. And this will be one of the last times I really tell you, but I think it's important in the last 10 years teaching this. I think students every time come back to me and they don't really understand how suddenly is a list there. But of course, the point is that the framework is doing something automatically in the beginning, right? So hence, when you see these interesting things where you have the list of all the elements there at the end, here's something happening in between. So let us start Microsoft Azure HD Insight Service. This is something, of course, that you already have seen. So I will go now to my cluster here that I already have generated. For the time's sake, I will not go into the same material for, we had already in lecture 3.1, how you create such a cluster. You remember, we can do it briefly, but I will not create one because I've already created one here You can see that here. And if you really want to create a new one, you remember we had to specify a resource group. We have already one. That is also the one you get for your assignment 1 access and assignment 2 access. We have this different region that we want to pick. And now the important thing is when we, for instance, take again Central US, remember we had the quota there. We have to select a cluster type. And here is now the point that we could use Hadoop, for instance, right? Which is now the pure Hadoop point of creating a cluster around still with many of the different stacks I was alluding to in the conceptual part, right? So Apache Hive, SQL if you want, pick for scripts and so on. And this is something what you could select, then you have to configure. If you remember, we have used a certain time last time Spark. So if you want to select this, you have different versions of Spark to play with. And then you have this kind of different passwords. These are important if you want to access, for instance, later the Jupyter Notebook. I don't do this now particularly, just making a couple of points that you have this Azure storage to have also a quota there, basically defined and registered if you want. Also, this was basically explained in lecture 3.1. And then when you come to the rest, you will see again, we could steer up the number of workers here, you know, from 4 to 2, for instance, which is now an important factor, of course, to realize how much workers we really have to work with. You will notice that for this simple word counts, I reduce the number of workers just because also we remember we talk about a cost per hour, although that's from our teaching costs here. I don't want to, let's say, spoil that too much. And then you review it, you create it, you would have, you know, the chance of creating a cluster to come back here more quicker. I had already created one, so to show you the recording a bit more in a straightforward manner, but I did the same steps I essentially did in lecture 3.1. Hence, we have now our beautiful HD Insight cluster available. I come back here, that of course is a similar things I have also on the slides here. That of course for your assignment, again, remember you don't have to really create this cluster, right? It is already created. I give you access through the resource group. And here what we now want to do is basically starting a Jupyter Notebook, right? So, and this is now the idea of where the password comes in for the admin and password. There, usually you would be asked for this. Here in my case, I'm basically already did this to verify that this all works. Hence, there's no question. It's still, you know, saved my password. But when you use it for the first time, usually you have to give this password. And I already uploaded a small, let's say, very short example to MapReduce. If you do normally the Jupyter Notebook there, you will have an empty space, right? It will be only PySpark and Scala here. So hence you have to upload, pick from your file system what you want to have, and then you basically would, you know, for instance, upload such a MapReduce Jupyter Notebook. So that is very similar like we did in the machine learning example around logistic regression the last time. And once you are in this environment of the Jupyter Notebook, you have to wait a bit. You remember kernel starting, please wait. You see that a little bit here also, that the kernel is basically busy starting itself. So hence in this time where we say there, you know, kernel not ready or waiting or starting, you should not do anything here. But you also realize in this URI here, we are now really remote, right? So there's nothing to do with the local installation of a Jupyter Notebook. Hence, we are now in the cloud using in MS Azure again, our HD Insight cluster underneath. I will do here a short restart and clear output, just because you see here still already the outputs of what I did before. And you see, okay, the PySpark kernel is ready underneath, so we import it. And also here you have to wait, right? Remember the star, it's quite of common knowledge in the Jupyter area. As long as there's a star, wait with the next cells usually, right? Because there are dependencies often. In our case, what we want to have, if you remember a bit about Spark, what we had in lecture 2, then in lecture 3, in practical lecture 3.1, etc. The idea is now that underneath the PySpark schedules basically, or prepares the scheduler yarn to to be ready for our MapReduce tasks, essentially, right? Or more broader speaking, for all the tasks. An important part there is that we have now a Spark session available and a so-called Spark context that you have available via SC here, for instance, that you can always use. You see also here we have an application ID. The yarn is starting, has nothing to do, is idle in the moment. There are more advanced topics where we can even go to UI and so on. Because of time's sakes, I cannot go into this. But of course, I encourage you to explore them more when you have the assignment, right? Then there's a bit more time. Now, let's go a little bit and see if we can get this README I was alluding to. Here, this food inspection data, there's this README file that has a bit of, let's say, metadata. And we want to use this just as an input of the data. The assignment would be a bit more fun because there's also more time. You can look at other, let's say, books and so on, that we will also discuss in assignment 2, which is coming up very shortly. But let us now think about the MapReduce world again. That is this example on. So we have this text file, this README, and I was already showing you very early in the Apache Spark lecture, really, that Spark is a very neat way of basically programming with these functions that you see there with Lambda, very quickly, something very smart. And if you remember the map task that we defined with source code and everything, or pseudocode as it was really in our slides, you could imagine the logic, the function logic was basically very, very, easy. So all what we add here a little bit is, of course, we want to go through this text file in a flat map line by line. And the line split is basically considered with this. So this is the first element that we define here with a lambda function. Then, of course, we come back to this. Hence, we can here have this simple notation to continue this just for readability. Here's a line break, right? But in a way, you see with one command, we can actually define the map and we can define the reduce task. But this is just, let's say, a very, very simple application. That's why we can do this. But in some summary statistics is actually the point that many of these things you maybe want to get out in this map and reduce world can be relatively simple and relatively simple computed. And here, no secret, we come back to our word count. So we would say we have these lines, and on these lines we go basically split them by this space apparently, hence making it a word. And a word is now something where we define the map task of saying just put word or comma 1 for each of those occurrences. So the same word, and even if we have several occurrences of this word, we would have basically coming out of this a long list with many words and always comma 1, comma 1, comma 1, comma 1. And even the same words would be not summarized or aggregated, would be still comma 1. That's the idea of the map task. Now we define then the reduce task of saying what's coming out there is basically then something we want to reduce by key. Now this is important. So by key, we already know that essentially everything has been sorted. You can also say shuffled around to the word key that we defined here. Hence, what's left is to say how we should do then the values that coming out, what we should do with those values. And of course, you can imagine this is also very simple. We would just want to systematically go through all of them that are having the same key and just say x plus y. Hence, we want, of course, to aggregate this. And by one line, which is quite interesting here, we have done now something which defines our map reduce task in a very straightforward manner. It has not to be that way, right? If you use Hadoop, if you use Mahout for machine learning, there are much more elaborate map tasks for machine learning tasks. And this is something what you, of course, can see in the open source. If you're interested, go to Apache Mahout, for instance, look in all the implementations that you have, for instance, for logistic regression, but also for, recommender engines and so on. They have lots of map reduce tasks already defined that then have a much bigger story to tell than just counting words. However, word count is simple. We can put that in a let's say 40 minutes lecture, the demo very nicely, and it captures the essence of what we want to do. Now here we now collect these words, basically showing you also that Spark is really working underneath with 3 executors and 6 cores. And what you would expect is then that we go, of course, for each of these words and counts in the in the results that you have from these MapReduce flat map, that you have essentially now the occurrence of the words, but aggregated, right? So we say the directory is coming 3 times. Many of the things as a small README file is just appearing once. The famous word the, of course, is appearing 5 times. Of course, provided here 3 times. You see a little bit the typical words that you would imagine is, in, this, is, these words that you would use in a sentence more and more would appear, of course, much more often. Hence, the word count would be higher. Okay, so that would be called rocket science in word count on steroids with Apache Spark, where argumentally, of course, for this in real life, you would not do this, right? So a README file might be something you can also do in your desktop. But it is something which captures the essence, and you can imagine now whatever large these files would be, the Spark engine in between can be still programmed like this, even if it's a gigabyte file, a terabyte file that we load in. Then the Apache Spark engine will break that into different chunks. Then you would see different executors very busy here in kind of these stages with different tasks and so on. And of course, then it would not take just 4 seconds. However, since we have seen MS Azure before, and you have now seen how Spark can be also programmed with map and reduce in a very, let's say, neat way here in a one-liner, I would like to move a little bit more further than to the Amazon Azure world, to the Amazon Web Services world. So all what I demonstrated is a little bit here on the slides. Basically, you see the same story in a way, but let us come now the remaining 10 minutes really for the AWS services. And we had this already shortly explored, that essentially, of course, there's no surprise that the big vendors, or cloud vendors, hyperscalers, if you want, with Amazon, for instance, also offer very similar services that we have seen in MS Azure. And for this here, it's called Amazon EMR for Elastic MapReduce. And the way it works is a little bit also shown here, that you see what of the big frameworks you really want to use. We will see that later. And this is based on the still infrastructure of service level, Amazon EC2. Now, infrastructure as a service will come in lecture 8. When we, let's say, work on assignment 2, we will, let's say, come back to the idea of conceptualized services layers, which I was alluding to in the prologue already, with infrastructure as a service, platform as a service, software as a service, which make use of each other, right? So you could say that you have this engine, Amazon EMR, and it uses, it's basically already a sort of platform, because you can use the EMR or the MapReduces for many different applications, right? It's a platform and infrastructure. But it's based on the hardware infrastructure of real CPUs, or if you want, even GPUs, on EC2, for instance. Hence, there's a dependency here. And then also the higher level services like Amazon SageMaker, which would be rather a SaaS service, really. It's already machine learning on steroids, but of course uses the underlying infrastructure here. And this is something we will come step by step throughout the course. Now we will focus a little bit on the Amazon EMR service and EC2 that I already basically have presented. So there are also different ways how you can use Amazon Web Services. There's an educate package, which shows you really nicely educational elements. There's an academy also for academic institutions. But the key message to take away is it's good for education. It's good for learning. But when we want to, let's say, really use an Elastic MapReduce service, it's basically not there, right? So the academy is, of course, something you can look in. You can go there in the University of Iceland and so on. But what we want to do is here a little bit focusing on MapReduce. And the situation is that there's a lot of free tier, let's say, hours, gigabyte storage that is actually provided for free. For instance, here in the free tiers that you see, But SageMaker, for instance, for machine learning, I was telling you, but you will not find the Elastic MapReduce service, right? And this is something which changed over some time. It's not anymore. That's why I write it. It was at some point in time, a couple of years ago, a part of the package. Now we have to use it by pay-per-use, which is not okay for students. So hence we have this also prepared. But the way how it works now, let's come a little bit to a demo. As I said, it is a practical lecture, so we leave here the space. Just one more thing, maybe while we are here still in this, you should always do a close and halt here of the Jupyter notebook itself, right? Which means it will close. And then in terms of stopping the Jupyter service, you should also do a quit to properly stop the Jupyter server. This is sort of important, and then close the tab. If you just close the tab, chances are that the server will still continue. Needless to say, if you're in a production environment, you also have to delete this service, right? But coming to Amazon, the console, you have here basically in Amazon, if you're already logged in, basically the console with all the different services, EC2, EMR, that's the ones we are particularly interested in, but you see also S3 that we will have in the second part, or SageMaker, I was saying to you, machine learning already on a quite broader scale. When we come to EC2, we will see also different options of creating, let's say, virtual images and so on. Examples I gave you a little bit in the virtualization lecture, not practically, but I also wanted to show you a little bit the key pairs here. And this is an important element. So before you go even to create Elastic MapReduce service or EC2 instances, you need to create a key pair, right? It has to have a certain name, a certain idea how you basically encode it. And then if you basically create this key pair, it will be stored, for instance, here in a PPK key store. And you will use later these information in part 2. I will show you today basically how you do this. Here you see I already created a key pair Ohio. This is of course something important because we are in the region of Ohio, right? So this is something also to realize. Amazon Web Services work in different regions, and the key pairs are also important to create for certain regions. Hence I do this here a little bit to also make the notion clear that we are looking now to create something in Ohio. And this is sort of the first idea what we have to do. Now, I know that some of you, of course, had not used SSH, so we will come to this in a moment. And also, I wanted to show you just very briefly, think about our Spark cluster that we had in MS Azure. Of course, the same is true for AWS. When you want these services in this region of Ohio, for instance, which really have high memory, you have to pay quite something for the hourly rate, right, of each of these. You see also then the difference between maybe $10 and $5 per hour, because there's basically also different storage solutions. They have the same memory, but this has this non-volatile memory SSDs, while here's an elastic block storage only. So there are different elements of storage also counting in the price. The network performance will be then different in terms of throughput and so on and so on. So here you see a little bit, it's not only memory, it's even also a little bit the storage which could affect the price. And also if you have then the really high level memory or large memory optimized examples, you pay up to $100 per hour. Of course, then you get lots of memory, and then you can understand quickly digesting terabytes now with lots of workers which have this amount of memory costs a lot, but on the other hand is also dealing with the terabytes much more quicker. Right, because it's all in memory. We have learned Spark really is then giving you lots of performance. If you don't want to do this and use Hadoop, then it's maybe much better to do some other ones that are much more here or very lower. We're basically here in this general purpose examples where you don't really need then have to have so much memory. Okay, but let's come quickly to SSH. This is something where this belongs in the pocket of almost all computer scientists as well. In order to basically go to this infrastructure here, the EC2, for instance, services, to create now an Elastic MapReduce on top of that, and then also leverage the S3, you have to have this SSH key pairs, right? And in lecture 8, we'll come back to this a little bit, but to understand this also, because we now create some, I just give you a simple explanation here where you have this key pair which belongs basically to you, basically personally. So you would have basically this created, and it belongs to you in a sense of having a private and public key. The public key you can upload without any problem, for instance, to the EC2, to the cloud. But you will notice when you create this care pair, for instance, the private key will be loaded down to your desktop, to your computer, laptop, whatever, and should never leave it, right? So the private key is yours, and the public key can be uploaded. Now, this is used then wherever you start an instance of a certain particular kind, that the server will then ask you, do you have the matching private key for the public key? And the HPC course talks about this in much more details as we here today. Just take away the message that this is the modus operandi in large, also when you do to ESC2 and the others, and you will usually have your private key pair protected with a password, maybe somewhere in a PPK file. And whenever a service will ask for it, if you have the matching key, you have to unlock this private key, probably with a password, and then can use it. Hence, you should never email it around. You should never give it to someone in order to, share your keys. That's not a good idea. However, how we did this key pairs, we already have done. You see here, the slides are basically the same. And in this sense, we have been gone through the majority. What I wanted to offer you today, the SSH client for Windows, I would recommend Mobile Xterm here as an example. For many people that ask me, for instance, Linux systems and Macs have often already an SSH client really integrated, so there's not a direct need. And my final slide would be just to think about that this AWS is really loaded. It has a marketplace with lots of solutions or solution tools that even are on top of these services that you have seen, and also in your assignment will explore, right? Assignment 2, and no secret, will have a little bit an exploration task, similar like MS Azure, that you should look through all the services. And then we also look at the marketplace a little bit. And just to give you a short message that, of course, Elastic MapReduce, that we will look into the second part much more. Here are 2 application examples of Airbnb where you can use this. Again, 50 gigabytes of data daily analyzed, for instance, in Airbnb, and then also the Spotify music, where you have basically this volume content is really an Amazon S3 accessible, and this is giving you also, let's say, the scalable idea of how you can access this licensed songs. This over 60 million is probably by now even outdated, might be much more. So I apologize for not updating this, but you can imagine Airbnb and Spotify of being really scalable is something we need. Again, also examples, we come to lecture 8 when we talk about more the idea of this elastic again. But this is all I wanted to leave you on the first part of the lecture, and we will come to more demonstrations then in the second part after 10 minutes break.